Hey guys, I am going to be out the rest of the week, so my plan is to still try to go through the lessons like we normally would. Um, that way we can still kind of stay on track for the rest of the year. Um, with that being said, I'm gonna upload these I'm gonna upload these videos so that we can kind of do notes like I would normally do with you in class. So everything is kind of similar in that sense. I'm going to go through it like we would in class. I really need you guys to listen to these videos with sound and watch them through rather than just kind of hopping around and just filling in the notes as it goes, because I want you guys to fully understand it like I would be doing in class. Okay? So these notes are covering the first two sections of chapter 7, and we're going to go through and talk about them. All of these notes are covering right triangles. So this chapter is really honing in on right triangles, and those are really the only types of triangles we will be talking about in this chapter. Okay, so the first thing, which you guys have learned before, is the Pythagorean theorem. The Pythagorean theorem is a theorem that allows us to figure out a missing side length on a right triangle if I know two out of the three of the sides. Okay, first off, if I look at my diagram of the right triangle, A and B, the sides that form that right triangle, those are called legs. And we kind of had already seen this before where I had said the side that's directly opposite your right angle is called your hypotenuse. So when you go to set up your Pythagorean theorem, you're always going to take one of the legs squared plus the other leg squared and set that equal to our hypotenuse squared. And in this case, the legs are labeled as A and B. So more often than not, you'll see the Pythagorean theorem listed as A squared plus B squared, and C squared is our hypotenuse, which is the hypotenuse squared. Okay, C is always going to be longer than A and longer than B. So C is always going to be the longest side length in a right triangle. There are common types of right triangles. So these are the most common side lengths for right triangles. You could have a right triangle with the side lengths of 3, 4, and 5. 5 would be your hypotenuse because it's the longest. You could have a right triangle of 5, 12, and 13, where 13 would be the hypotenuse. You would have a right triangle with a leg of 8, leg of 15, and a hypotenuse of 17. And similarly, you could have a right triangle with a leg of 7, leg of 24, and a hypotenuse of 25. You can also have any version of the multiples of those, right? So you could double all of these. This would still be considered a right triangle. You could multiply all these by 3. This would still be considered a right triangle. Multiply them all by 10. It'd still be considered a right triangle. So these are the most common Pythagorean right triangles. They're called Pythagorean triples. So it would be helpful if you remember at least these 4 different side lengths here of these Pythagorean triples. But if you can't remember them, it's still not a big deal because we'll still end up using the Pythagorean theorem to prove if a triangle will be a right triangle or to help us find that missing side length. Okay, so just some examples there. In my example here, it says identify the unknown side as a leg or the hypotenuse, then find the unknown side length of the right triangle. In this case, x is one of the sides that makes up the right angle, so x is considered to be a leg. 5 is the side length that's directly across from the right angle, so this is our hypotenuse. So we're looking for a leg here. From the Pythagorean theorem, if I labeled this, one of my legs is A, one of my legs is B, one of my legs is C. So if I wanted to solve this out, I would put x squared plus 3 squared, because I'm taking A squared plus B squared, and I would set it equal to 5 squared. We're always setting it equal to the hypotenuse squared, whether the hypotenuse is the side length we're looking for or whether we are actually given the side length. Okay? If I wanted to solve this, I would keep the x squared. 3 squared is the same as saying 3 times 3, which is 9. 5 squared is the same as saying 5 times 5, which is 25. If I wanted to solve this, I would subtract 9 And at this step, I get x squared is equal to 16. I need to figure out what just x is, which means I can't have this exponent right here. The operation that we have to take to cancel out the exponent is a radical, a square root, right? Basically, you're asking yourself, what times itself is equal to 16? In this case, I know that 4 and negative 4, right? 4 times 4 is 16. Negative 4 times negative 4 is also 16. But because we're looking at it in terms of a side length, we're only looking at the 4 because I can't have a side length that's negative 4 in length. So in this case, I'm taking x as 4. Okay. If we had a number here that wasn't a perfect square, right? Like, so 16 is a perfect square, 25 is a perfect square, 9 is a perfect square because 3 times 3 is 9, 5 times 5 is 25, 4 times 4 is 16. Those are all perfect squares. If this number wasn't a perfect square, I would still take the radical. So you would take your calculator and you would plug in the radical button. If you look on your calculators, you would hit the second button and then the button that has like that exponent of 2, it's like x squared. You can see that if you hit the second button, it'll give you the radical. You would just take it as a radical and you would just put it as a decimal. Okay, we'll actually see that in this example on number 2. So in this case, x is directly across from the right angle. So that means that x is my hypotenuse. So when I'm going to set this up, again, 6 and 4 make up my right angle. That means that those are my legs. My hypotenuse is always c. So when I go to set this up, I take 4 squared plus 6 squared, and that would equal my hypotenuse, x squared. 4 squared, or 4 times 4 is 16. 6 squared would be 6 times 6, or 36. I would add those together, and I would get that x squared is equal to 52. This is where I was saying this is not a perfect square. You can't multiply anything times itself to get 52. So this is where you would hit the second button on your calculator. You would hit the x squared button, and that would result in giving you a radical. So you're going to take that radical, you're going to plug in 52, and it should spit out a decimal back to you. If you round it, it should round to 7.2. Okay? These are the buttons you press to get this decimal. This is what it's going to input in your calculator. Okay? So your hypotenuse here is 7.2, which if you compare it to your legs, that makes sense because 7.2 is longer than 4 and it's longer than 6. So, and it's kind of relative in the side lengths there, right? We're not getting anything crazy like 423. That wouldn't make sense with these side lengths. Okay, so our hypotenuse there, x, would be 7.2. In my next example, we're talking about the area. It says find the area of the isosceles triangles with side lengths 10 meters, 13 meters, and 13 meters. The first thing that I want to remember is that the area of a triangle is 1/2 times the base times the height. If I'm looking at this entire triangle, I have some of these values, right? I'm keeping the 1/2. The base is the base of the entire triangle, right? This is your base. So you would add those together. The base would end up being 10. What we don't have is the height of the triangle. So that's up to us to help figure out what it would be. If you notice, this line is drawn cutting your triangle in half, and it's forming this big triangle into 2 smaller right triangles. So you can treat the left or the right triangle here and use your Pythagorean theorem, right? That'll help you figure out this missing length, h, of your entire large triangle. So h, you can see it's making up the right angle here, one of the legs making it up. So h is a leg. So I'm going to have h squared plus 5 squared equals 13 squared, right? We're going to keep the h squared. 5 squared is 25. 13 squared is 169. When I subtract the 25 from both sides, I get h squared is equal to 144. And you can plug it into your calculator, or if you know off the top of your head, 144 is a perfect square. When you take the square root of 144, you would get 12. So we just did the Pythagorean theorem to help us figure out what h is. That way I can plug it back up into my area formula. So I'm going to take my area as 1/2 times 10, which is 5. 5 times 12 tells me my area is 60 meters squared. So you're applying the Pythagorean theorem on one of these right triangles here to help us find the height. That allows us to then plug in the height into our area formula. Okay. I want you guys to try 5 and 6 on your own. So go ahead and pause the video. When you come back, I will give you the answers and hopefully yours will match up. Okay, so pause the video now. Okay, so with this on number 5, if we were to set it up, we're looking for the h again to help us figure out what the area of the triangle would be. So we don't have the h, we're applying our Pythagorean theorem. Something you have to keep in mind on this is when you're applying your Pythagorean theorem, you're only looking at this side length, or you're looking at this side length here, right? That's not 30 feet, that's half of it. That's 15 feet. So when you set up your Pythagorean theorem, we should be doing h squared plus 15 squared equals 18 squared. And I'm not going to do it all out, but when you solve all of that down, we should get h is equal to 9.9. So when I plug that into my area formula, my base now talks about the entire base of that triangle, which is 30, and then you can use your height as 9.9. So again, your area here would be 148.5 feet squared. So just something to be careful about on 5 and 6. Same idea on 6. 20 refers to the entire base of the triangle. So when you're looking at your Pythagorean theorem, you're only looking at half of that. So again, area is 1/2 the base times the height. You're going to set up your Pythagorean theorem as h squared plus 10 squared equals 26 squared. I'm not going to do it all out, but you should get that h is 24. And when you plug that into your area formula, again, base refers to now the entire base of the triangle. Your height is 24, so you should get your area as 240 square meters. Okay, so just be careful about those on 5 and 6. Okay. We're going to also use what we know to help us find more missing side lengths on these examples here. Okay, with this on number 24, I have these little tick marks here telling me that this side length is 6, which means that this side length is also 6. So if I wanted to find x, looking at now just the right triangle, x is going to be my hypotenuse. So I would set up my Pythagorean theorem as 3 squared plus 6 squared equals h squared. That's going to give me 9 plus 36 equals x squared. And we can add those together. We get x squared is equal to 45. And again, this is where you would hit the second button, and then you would hit the x squared button so you can get that radical. So when you plug in the radical, or the square root of 45, you should find that x is equal to 6.7. Okay, same idea on 25. We have all of these tick marks here. That means this side length is 11. This side length is 11, right? Same idea. X is our hypotenuse, so I'm going to set it up as 11 squared plus 11 squared equals x squared, which is 121 plus 121 equals x squared, which means I have x squared equals 242. And again, same process. Second, hit this x squared button. That's going to tell you that when you take the radical, or the square root of 242, x would equal 15.6. Okay. To find x on number 26, we really can't do that unless we find out what this side length is, because x is a part of this right triangle here, which only is giving me a length of 7. I don't know what this side length is, and I definitely can't assume that this entire triangle is a right triangle, because there's nothing telling me that this angle right here is a right angle, or that's telling me that the other angles are right angles. So I have to find this length first, because what I do know is that this angle must be a right angle as well, because it's a linear pair. So I can figure out, either using the Pythagorean theorem, or if you remember, if you go back to your Pythagorean triples, 3, 4, 5 was a Pythagorean triple. I have a side length of 3, I have a side length of 5, which means that this side length must be 4. And if you didn't remember your Pythagorean triple, you can still figure that out, right? Let's say I called this side length y. Y is going to be one of my legs, so I would do y squared plus 3 is my other leg, so 3 squared equals my hypotenuse squared. I'd get y squared plus 9 equals 25. Subtract the 9 and take your square root, you'll still get that y is equal to 4. Now that I have this side, now I can go figure out what the x is. So now x is my hypotenuse, 4 and 7 are my legs, so I'm going to set it up as 4 squared plus 7 squared equals x squared, or 16 plus 49 equals x squared, which means x squared is 65. And again, same process, hit the second button, hit the x squared button, that gives you your square root. The square root of 65 would tell you that x is about 8.1. So you can round to the nearest tenth in this place. I know that it says round your answer in simplest radical form. We really haven't gotten to go over that yet, so for the sake of this, just keep it as a decimal for now. Okay, those are your answers on there. The next thing that we want to look at is the converse of the Pythagorean theorem. So we had said in the previous theorem that if I had a right triangle, then a squared plus b squared equals c squared. In this case, if you have a triangle with 3 lengths, so you already know the side lengths, if you have a triangle and you're given the 3 side lengths, you can apply the Pythagorean theorem to check to see if it's a right triangle. Basically, if you apply the Pythagorean theorem and it works, then you can automatically assume that it's a right triangle. That's what the converse of this Pythagorean theorem means. So let's see that in action. If I look on the examples of the next page, first off, I'm going to do B first, and then I'll go back to A. Okay? On B, I have side lengths 22, 14, and 26. Okay? Remember that your hypotenuse should always be the longest side. So although the right angle is not written, you know which side is your hypotenuse because it's going to be the longest side. So I would treat 26 as my hypotenuse. So I'm going to test out my Pythagorean theorem. I'm going to take one leg squared plus the other leg squared, and I'm going to set that equal to what would be my hypotenuse and square it. If I do 14 squared, I get 484. If I do 22 squared, I get 196. And if I do 26 squared, I get 676. If I add these together, this adds up to 680. This gives still stays as the 676, and 680 does not equal 676. That doesn't work, which means that this is not a right triangle. If it did work out, if I got 680 equals 680, or if I got 676 equals 676, that's where I would confirm, yes, that triangle will be a right triangle. Okay? The reason I wanted to hold off on letter A is because we have to talk about the rule of squaring something that has a square root. Okay? If you plug this into your calculator and turn it into a decimal first, you should be able to see that this is going to be the longest side out of these 3 sides here. So this is what we are going to treat as our hypotenuse. So just setting it up, I'm going to have 9 squared plus 15 squared, and I'm going to take 3 square roots of 34, and I need to square that. On the left side, I can do 9 squared to get 81. I can do 15 squared to get 225, but we need to talk about how I square this. If I have 3 square roots of 34 squared, that means I'm going to square the 3, and I'm also going to square the square root of 34. This we know is 9, right? 3 times 3 is 9. The square root of 34 squared, we had talked about before that the square root, the opposite of it, is the exponent of 2, right? That's why up above when I did x squared equals 242, I took the square root to get this answer here. It's because the square root and the exponent of 2 cancel each other out. So right now, when I square 3 square roots of 34, the 3 squared is 9. I'm left with just the number underneath that radical when I square that radical. So I'm actually doing 9 times 34. So when I go and add these together, I get 306. And 9 times 34 is also 306. So in this case, this is a right triangle because they are equal to each other. So again, anytime you have something with a number on the outside and then a radical and you have to square it, you're squaring the outside number and you're multiplying it by the number that was inside your radical, because the radical and the exponent canceled each other out. You're just left with that inside number. Okay? I want you guys to try 1, 2, and 3 on your own. Again, you have some that have the radical, so be careful with that. But go ahead and try 1, 2, and 3. Go ahead, pause the video. Okay, now that you've paused the video, all of these you can see are kind of set up that this is the short side, this is a shorter side, and this is the longest side. Again, you could plug it into your calculator and just double check to see if this would be your longest side by doing 4 times the square root of 3. But this is going to be your medium length side. So I would set this up as 4 squared plus 4 square roots of 3 squared equals my longest side, 8 squared. 4 squared is going to give me 16. Here, I'm going to square the 4, right? 4 squared, 4 times 4 is 16. And I'm going to cancel out the radical with the exponent and multiply it by just that number that was underneath the radical. So 16 times 3 and then 8 squared gives me 64. 16 times 3 is going to be 48. So 16 plus 48 is 64. I get 64 equals 64. They're equal, so this means that a triangle with those 3 side lengths would be a right triangle. Same test on number 2. Try out 10 squared plus 11 squared equals your longest side, 14 squared. You'll get 100 plus 121 equals 196. This is going to give you 221 equals 196, which means since they're not equal, this is not going to be a right triangle. Okay, and this last one, again, you could test this out in your calculator, get the decimal version to make sure that this is the longest side, which it is. So I'm going to set it up as 5 squared plus 6 squared equals the square root of 61 squared. Okay, 5 squared is 25, 6 squared is 36. When you square the square root of 61, there's no outside number that you need to square. You're just canceling out the exponent and the radical, and you're just left with 61. So when I have 25 plus 36, I also get 61. 61 is equal to 61, so that means that these side lengths would form a right triangle. Okay, so that's our test on the Pythagorean theorem. We're going to build off of that a little bit. We basically were just saying if these triangles or if these side lengths could form a right triangle or if they couldn't. If they could not form a right triangle, we can go a little bit further. Okay, think about it as your hypotenuse. If you have a hypotenuse squared, right? If your hypotenuse, if c squared is larger than a squared plus b squared, that means you can have an obtuse triangle, right? So if they're not equal, right, meaning they're not a right triangle, if you notice that your hypotenuse squared is a bigger number than the sum of your legs squared, then you know that you don't have a right triangle, you have an obtuse triangle. Same goes for if your hypotenuse is smaller. So if your hypotenuse squared is less than the sum of your legs squared, then you have an acute triangle. Okay? So no, those triangles would not be considered right triangles, but if they're not right triangles, we can go one step further to just figure out, well, would they be an obtuse triangle or would they be an acute triangle? Okay? These are my 3 rules kind of written out here. If c squared, or if a squared is plus b squared is equal to c squared, so if your Pythagorean theorem works out, then you have a right triangle. If your hypotenuse squared is smaller than the sum of your legs squared, then you have an acute triangle. And if your hypotenuse squared is larger than the sum of your two legs squared, then you would have an obtuse triangle. Okay? So let's see these done out here. And my next example, it says, can segments with lengths of 4.3 feet, 5.2 feet, and 6.1 feet form a triangle? If so, what would the triangle be acute, right, or obtuse? So one thing that we didn't necessarily talk about yet is if a triangle was going to be a right triangle. Oh, hold on, my thing just died. Give me 1 second. I'm gonna give you guys a part 2 video to this so I can finish up because my tablet just died. So I can't write on the notes. So give me a sec, click onto part 2 video, and I will pick up where I left off there.